Hi, this is Heather Ringstaff, and this is my video demonstration 2. And I went ahead and wrote down a lot of things just because I didn't want the video to take so long, so I hope that's okay. What I am attempting to prove today, get my camera straight, is I've been given this span of vectors, and initially I'm going to sketch the proof of using the column correspondence property. And basically, I'll just explain what that means. I've looked it up, and it's a property or principle that states that any linear dependence of the column of a matrix A is also found in the columns of the row reduced echelon form of the matrix A. And it follows that the pivot columns of the matrix A form a basis from those same pivot columns of matrix A. So the first thing I was going to do is see if the vector that was given, 2, 5, 5, 10, was an element of the span of S. So basically that just means is the vector a linear combination of the vectors in the span of S. So I identified scalars C1, C2, C3, C4, and I set up a matrix equation, and I formed the augmented matrix, and I used technology to get the row reduced echelon form, and this is what I got. So I knew I was going to have to write my solutions in terms of, and what I did was I wrote C1 and C2 in terms of C3 and C4. So I got the solution was 2 minus C3 minus C4, then 1 minus C3 plus C4, and then C3, C4. And I did check this, and I can send that to you if you want to. I plugged these back in to make sure I indeed got 2, 5, 5, and 10, and I did. So therefore, the vector 2, 5, 5, 10 is in the span of S. And the next thing, I was asked to find a basis for the span of S. So in order to do this, I formed a linear combination from those vectors in the span, and I set them equal to 0 and made an augmented matrix. And again, I used technology to do the row reduced echelon form. And the pivot columns were just columns 1 and 2. And according to CCP, those pivot columns are going to form the basis for, or these two vectors are going to provide a basis for that span. So these were my original two columns in my original matrix, 1, 2, 3, 4, 0, 1, negative 1, 2. So therefore, these two vectors will provide a basis for the span of S.